Welcome to another Mathnificent conversation featuring rationalizing the denominator. It's your nerdy bestie Lex, and today we're going to talk about why we rationalize denominators, how to rationalize denominators. So grab your pencils and let's go. Rationalizing denominators isn't something that usually is a standalone topic. It's usually a part of a bigger topic, but it's important for making sure your answer is simplified completely. Standardized tests, your exams at school, most of them will require you to rationalize any denominators. So you'll lose points if you're not comfortable rationalizing the denominator. It's a very easy way to just make sure you're getting all of your points and simplifying your answers completely. If you end up with an answer and there's a radical in the bottom, so say for example, 5 divided by radical 2. This is a denominator with a radical, so it has an irrational denominator. So we're going to rationalize it. The trick that we use in math is you can multiply any expression by 1, and it's going to remain an equivalent expression because anything times 1 is equal to that same thing. That's our identity for multiplication. So we use that trick a lot, and rationalizing the denominator is one of the times that trick is used. So I'm going to do a quick example with this 5 over radical 2. I'm going to multiply by 1, but that 1 is going to look like radical 2 divided by radical 2. We all agree that a number divided by itself is 1. So this expression that I'm multiplying by is the same thing as 1, but I'm going to use it to my advantage. So then we multiply fractions straight across. This is 5 radical 2 divided by radical 2 times 2. Now, if you haven't checked out Simplifying Radicals video and you're unsure how this works, check that video out. If I have a pair of twins under a square root, I circle up those twins, and that tells me I can bring that 2 out. So this is 5 radical 2 divided by 2. Now my radical is no longer there. You can also think about this as the square root of 4, which we know is 2. Either way you want to think about it. But the reason we're multiplying by radical 2 over radical 2 is I know it's going to create a perfect square in my radical that I'll be able to simplify so that it no longer has a radical. Last thing we check, can we divide 5 and 2? No, it does not simplify. So we leave our answer as 5 radical 2 divided by 2. Okay, now we have 6 divided by radical 3. We have a radical at the bottom. Doesn't simplify down, so we have an irrational denominator. So we want to rationalize it. We choose to multiply by a form of 1 that looks like our denominator. So radical 3 divided by radical 3, which we know is equivalent to 1. So when we multiply straight across, we have 6 times radical 3 divided by radical 3 times 3. I have a pair of twins I can circle and bring out. Nothing is left under the radical. So that means I have 6 radical 3 over 3. Again, you can think about this as the same. 3 times 3 is 9. The square root of 9 is 3. In this case, we can simplify the numbers outside of the radical. 6 divided by 3 is 2. So our final answer is 2 radical 3. Okay, now we have radical 7 divided by radical 5. Remember, it's only irrational numbers in the denominator that are a problem. So the radical 7 isn't the issue, the radical 5 is the issue. So again, we multiply by an equivalent form of 1 that looks like our denominator. So radical 5 divided by radical 5, which we know is still equal to 1. When I multiply straight across, I can multiply like radicals together. So that's radical 7 times 5. And at the bottom, this is radical 5 times 5. I have a set of twins I can circle and bring out. We remember this is the same thing as radical 25, which is 5. So at the top, we have radical 35. At the bottom, we're left with 5. We cannot divide into a radical unless it's also a radical. So this is our final answer. Radical 35 divided by 5. Sometimes you'll have a coefficient in front of the radical. 4 is what we would call a coefficient in front of the radical 5. What we have to keep in mind is numbers outside of radicals can be multiplied, numbers inside of radicals can be multiplied. But a number outside a radical cannot be multiplied into a radical. So we keep our same routine. We're multiplying by an equivalent form of 1 that looks like our denominator. So that's radical 10 over radical 10, keeping in our mind that this is equivalent to 1, and that's why I'm allowed to do this. Now, if you haven't watched the prime factorization video with simplifying radicals, I would suggest you do so, because when I multiply these at the top, I want to see this as 5 times 5 times 2, because 5 times 2 is equivalent to 10. And it's easier to simplify your answer completely when you see the prime factorization. So then at the bottom, we have 10 times 10 under our radical. I have a set of twin 10s that I can bring out of my radical at the bottom, but I also now have a set of twin 5s that I can bring outside my radical at the top. So at the top, I now have 4 times 5, and under my radical, I'm left with 2. And at the bottom, I'm left with 10. 4 times 5 is equivalent to 20. Radical 2 over 10. And we can simplify down one more time because 20 divided by 10 is 2. So 2 radical 2 is our final answer. Okay, our last example has coefficients in front of both our radicals. So we're going to practice knowing which numbers we can multiply and which ones we can't multiply. Remember, the radical in the numerator is not what I'm worried about. It's the radical in the denominator. And I'm not worried about the coefficient. That's a very important part that people mess up on. You only need to multiply by the radical. The 5 is not necessary. It will take care of itself when we simplify. So at the top, I have 8, and then I have radical 3 times 2. And at the bottom, I have 5 times radical 2 times 2. I have a set of twins that I can bring out at the bottom. So I have 8 radical 6 divided by 5 times 2. Okay, so this is 8 radical 6 divided by 10. 8 divided by 10 can both be simplified by a factor of 2. So 8 divided by 2 is 4. And 10 divided by 2 is 5. So our final answer is 4 radical 6 divided by 5.